Okay, this is Utah Middle School Math Project 4.3b, Solving Proportions. Our last lesson was 4.3a, where we focused on writing proportions. Today is the day that you get to do the thing that was killing you not to do yesterday. You actually get to solve the proportions, but we're going to go through a nice slow process to introduce ourselves to how we're actually doing it. One of those keys to see how we solve these is going to be in naming these properties. In Part A, Part B, and Part C, there is a specific property that is being demonstrated by the statement. I want you to go back deep into your memory and see if you can come up with the name for each one of these properties. You can discuss with your groups. You can use your own brain. You can even go back and look things up if you have notes that might say it. We're going to pause the recording as you give yourself a chance to do this. Ready, set, go. Part A. What is the name of this property? What is the name that we see here? You want to give it a try, Carter? It is not commutative. Good guess. It is not commutative. Commutative does mean that we're rearranging the order of things, but we're not necessarily rearranging the order when we're flipping it like this. Any other thoughts? Any other guesses? Sophie? You are really stinking close. Yes. This is called the multiplicative inverse. Multiplicative, where does that word come from? Multiplication. We're multiplying. Voices up. What does inverse mean? Do you guys know what inverse means? Gideon, give it a try. Yeah. Yeah, exactly. When it's being multiplied by its reciprocal. So you can see, and that's something else that's worth noting, notice that these two are reciprocals. Okay, and the multiplicative inverse, exactly as Gideon said, when a number is multiplied by its reciprocal, what is the result? What do we get? 1. How about B? Anyone have a guess on B? Grant? It is identity, yes. The multiplicative identity, to be precise, multiplicative identity. Essentially, what's happening is we have 1 multiplied by mn, and anything multiplied by 1 is itself. So 1 times mn is equal to mn. Multiplicative identity. Identity meaning it stays the same. C. This is one that I know for sure you were taught in previous years. The question is, do you remember it? Grant, you think you might know? Okay. We're adding numbers to both sides, but when I added the number, is it really adding the number? Which is why you said multiplicative, additive. But what are we really doing, Carter? You're close. Multiplication property of equality. You've seen this one before. You have done this one. You've used this one even this year as we have solved equations. Look at the original. It helps if you just focus on the original right here. X is being divided by 2 and it's equal to 8. How do we undo division? With multiplication. So what are we doing here? We're multiplying. We're multiplying specifically to undo this division, but here's where that property of equality comes from. If I'm going to multiply this side by 2, I have to keep it balanced and multiply the other side by 2. Okay, so that's the multiplication property of equality. It's okay to multiply an equation as long as you multiply both sides of that equation to keep it equal and true. All right. So, since the name of our lesson is solving proportions, we need to understand what it means when we're solving something. So, to solve equations, you need to first understand how the equation is built. So I always ask the question, what's happening? What's happening to the variable? Once you identify what is happening, you need to then ask the question, how do I undo what's happening? And then finally, once we know how to undo it, make sure that we keep the equation balanced and we do the same things to both sides. So let's practice this. This first one is very easy. Here's the variable. I've identified the variable. Now, what is happening to the variable? Thank you for the hands. That's your cue. You should all be raising your hands. Remember, these are the easy ones. Oren. Yes. Next question then. Now I know that we're multiplying by 7. How do I undo multiplying by 7? Luke? We divide. And again, as long as I do it to both sides, it's going to stay balanced. So I'm going to divide by 7 to undo the multiplication. Whatever we do to one side, do it to the other side. Nice and easy, right? Times 7 divided by 7. The whole reason I chose to divide by 7 is so that that part is undone. It divides out. And it leaves me now with x is equal to 42 divided by 7 is equal to 6. Next one. Here's x. What is happening to x? What's happening to that variable? Tanner. We're going down instead of over. Look at this one here. That's a multiplication sign? Yes, we are dividing by 9, exactly. That's a division sign. We're dividing by 9. Now that we know what's happening, how do I undo dividing by 9? Devin. We multiply by 9, and it's okay to multiply by 9 as long as I do the same thing to both sides. So I'm going to multiply this whole side by 9. I'm going to multiply this whole entire side by 9. And even though this looks weird, just remember the whole reason we chose to multiply by 9 is specifically to undo dividing by 9. Those are inverse operations. They undo each other. So I am left with x, which is equal to 4 times 9 is equal to 36. Okay, the others are just as easy. Maybe the notation is a little bit different. Maybe the answers are not going to be quite as comfortable, but our processors are going to be the same. I'm going to let students work on ahead just a little bit. But answer this question. What's happening to x here? Tanner. Yeah, we're multiplying by 5. Even though I'm too lazy and I don't have the dot to show that it's multiplied, we understand when they're squished together, we're just lazy, and that means 5 times x. This is notated a little bit differently here. What's happening to x in this one? Look at this one here. What's happening to x here? Laroya. We're dividing, yeah. So even though I'm not using this old-fashioned division symbol, we know that this is division. Okay, so with that in mind, I'm going to let you guys work on a little bit ahead. You might have some struggles, but give them a try. I want you to solve the rest of these equations with your groups. Ready, set, go. All right, these first two were pretty easy. As we already discussed, we're multiplying, so I'm going to undo multiplication with division. Whatever I do to one side, I do it to the other side. The whole reason I chose to divide is to undo the multiplication, so I know that that part divides out. And I'm left with x is equal to 35 divided by 5 is equal to 7. Remember, we're dividing by 2, and I undo division by multiplication. Whatever I do to one side, I balance it and do it to the other side. So again, even though this looks weird, we don't need to worry about it because the whole reason I chose to multiply by 2 is specifically to undo the dividing by 2. So that part is undone. And I now have x is equal to 7 times 2 is equal to 14. Oh no, there's fractions. I don't know how to do math when there's fractions. Please understand, folks, the process is no different than what we did over here. So many times I get students freaking out because now there's all of a sudden a fraction, but a fraction is just a number. You weren't worried when the number was an integer. You shouldn't worry when it's a fraction. Our process is still the same, and especially because you guys have really cool calculators that will help you out with that too. X is divided by 7. I undo dividing by 7 by multiplying by 7. Whatever I do to one side, I do to the other side. This part divides out, multiplies out actually, and I'm left with just x is equal to, calculators if you need them, but 10 thirds times 7 is the improper fraction 70 thirds, yeah? Okay, and fractions are friends. I don't want a mixed number here. Fractions are friends. Put a box around it. We like that number. Big, grown-up, junior high kids don't use mixed numbers anymore. We keep them improper fractions. And what about here? D is just divided by 8. So we don't need to freak out. We just know that we undo dividing by 8 by multiplying by 8, doing the same thing to the other side. Remember, this multiplies out. Multiplication undoes that division, so I am left with D all by itself on the left side. 5/2 times 8 is equal to 20. So was it really scary doing it with fractions? No, fractions are friends. It's fine. So remember, let's back up for just 1 second. What we talked about in our last lesson, we were writing proportions. So let's do a quick review here. We were writing proportions, remembering that a proportion is simply a ratio equal to a ratio. Okay, we filled this in with like an A over B is equal to C over D, right? It's just a ratio equal to a ratio. So what I want you to recognize on this set of problems, I need to scroll down. On this set of problems here, do you see how it's a ratio equal to a ratio? We treated it as if we were just solving an equation, but we were solving a proportion because it was what looked like a fraction equal to a fraction, or a ratio equal to a ratio. So what we're going to do here is we're going to solve this same proportion, what is it, 4 different times. We're going to solve it 4 different times. So what I want you to understand first and foremost, it's not the answer that we're interested in. We're going to find the answer this very first time we solve it. All the other times, it's the process. Is that understood? Focus on the process. We're going to learn a lot from that. So here we have this equation, or this proportion. X divided by 3 is equal to 9 divided by 5. Each time we take a solving step, because we're going to do these solving them different ways, we want to justify what we're doing. So here is the problem that was given to us. The justification that we're going to put on this line is given. That is the problem that was given to us, so just given. But now we need to take a step. So what I'm going to do is I'm going to copy down that problem. X divided by 3 is equal to 9 divided by 5. Treat this just like we did over here, right here, right? It's just a variable being divided by a number. How do I undo that division? X is divided by 3. All we're going to do is multiply by 3. Okay, whatever I do to one side, I do it to the other side. Right? Now, what is the justification that allows me to do that? We just reviewed that property over here. That justification, it's okay to multiply as long as we do it to both sides, is the multiplication property of equality. So that's what we're going to write here. That is our justification. Multiplication property of equality. I would also like to note that the reason I chose to do multiplication and needed to use the multiplication property of equality is specifically because I wanted to undo the division that was happening. So I'm going to also write that down too. I chose to do multiplication property of equality to undo division. And we have one final row, and so what I do in this row is I'm going to simplify what we did in that previous step. So what happens when I divide by 3 and multiply by 3? It is undone. That leaves me here with just x, which is equal to, on the other side, calculators if you need it, but I'm hoping that you know those, how to multiply the fractions. We end up with, Grant, you know it? Exactly, 27/5. Folks, don't forget, this is the answer that we're going to get every time, right? So again, it's not about the answer, it's about the process. What is the justification that we put here? I'm just going to put, we just simplified the previous step. We just did those calculations that we said we were going to do. This is actually what they call a 2-column proof, where you take your steps, but then you give the justifications on the other side. It's an important math tool when you get into more advanced mathematics. Example 2. First things first. Here's our equation. Will you please compare this problem to the one before? What's similar, what's different? And then we're going to solve. But I want you to first compare, quick discussion at your tables, compare this one to our existing one. Ready, set, go. Okay, what do you know? Tell me what you saw when you compared them. Davin? Yeah, exactly. We saw that last time, right? That was what our whole lesson yesterday was about, is flipping it to its reciprocal. So that's exactly right. What is happening, or compare, this is just the flipped version. This is the reciprocal of the last problem. So understand, they are the same problem. This would be like I wrote the first one and now I flip it to its reciprocal, and here is the second version. So let's solve this second version. Here is where I want you to be a little bit careful. When I ask what's happening to x, I want you to be really careful. Ignore, just cover this up for a second. Say this left-hand side of the problem. How would you say that? Grant? Yeah, x is dividing 3, right? 3 is divided by x. So here's an interesting thing. What is happening to x? Nothing. X is doing the things, right? Nothing is happening to x as it was in the last problem. Compare it to this one. X is divided by 3 here. 3 is divided by x. So where the x is makes the problem a little bit different. So what is happening? Oh, sorry. We're going to do this first. This is our given. Now let's talk. Is dividing by 3 going to help? Talk with your groups. Is multiplying by 3 going to help? Talk with your groups. What are we going to do to start solving this? Okay. Come back to me. I hope that you can see at this point that multiplying by 3 isn't going to help. Dividing by 3 isn't going to help. X is still going to be down here on the bottom. So that's the first problem that we need to address. How are we going to address that, Carter? Yeah, we're going to multiply both sides by x. Watch what happens when I do that. Up here, when I had 3 in the denominator, I got rid of it by multiplying by 3. Now I have x in the denominator. So how am I going to get rid of it? Multiplying by x. That's okay. As long as whatever I do to one side, we do it to the other side. What is the property that tells us we can do that? Multiplication, property of equality. I'm feeling lazy. I'm not going to write property of equality, POE. Yep. I am still writing the word multiplication, but I'm just going to write property of equality, POE. Why am I doing that? Because I'm trying to undo the part where x was dividing the 3. So I'm still undoing division here. What does this look like? Well, when I have 3 divided by x that's then multiplied by x, that part's going to undo. Okay, so what is it that I'm left with? Just a 3 on the left-hand side. And on the right-hand side, yes, Grant? Yes, I'm going to write it a little bit differently, though. You're right. You could write 5x divided by 9. I'm going to keep it as a fraction multiplied by x, 5/9 x. Okay, just for the sake of consistency, I'm just going to keep it like that. But you are correct. And what's the justification here? We just simplified the previous step. We just simplified. All right, now, again, I'm going to copy down the last step so that I can now make some adjustments and make some changes to it. Ask the question again, what's happening to x now? What is happening to x? Davin. Exactly. How do I undo multiplying by 5/9? Careful how you answer. I want to see more hands. I said careful so no one wants to raise their hand. Gideon, how do we undo multiplying by 5/9? Yes, you're exactly right. Most students want to say we undo multiplication with division. Is that true? 100% true. But when we have fractions, we have another strategy. I can undo that by multiplying by the reciprocal, using that multiplicative inverse, and that's what I'm going to apply here. So I'm just going to spread this out a little bit here. Let me rewrite it, I'm sorry. What I'm going to do is I am going to multiply both sides by the reciprocal, 9/5. And that's okay to do, as long as I multiply the other side as well. So both sides are being multiplied by 9/5. What says that I can do that? Multiplication, property of equality. However, we're choosing multiplication to get rid of multiplication because we're using the multiplicative inverse. So I want to include that as well. Multiplicative inverse. Nice job, Gideon. All right, what happens when I do all of those things? What happens here when I have 9/5 times 5/9? Carter? Yeah. Exactly, a number multiplied by its reciprocal is 1. We saw that with the multiplicative inverse. And for those who maybe don't catch on quite as quick, 9 times 5 is 45, over 5 times 9 is 45, 45 over 45 is 1. So all of this here simplifies to just 1. Well, what is 1 times x? It's just x. We're lazy, right? We just say it's x. It's 1x, but if I have 1 dog, I have a dog. If I have 1x, I have an x. Okay, just lazy in our mathematician, lazy in our speech. And 9/5 times 3, we already know this from before. 9/5 times 3, calculator, if you don't know it, is 27/5, just like it was before. How did we get to that point? We simplified. That is version 2. That was quite a few steps, wasn't it? So you have this version where really truly it was 1 step and then we simplified. This one, look at how many steps. 1, simplify, a second one, simplify. What we're going to do, example 3 says, let's do it again. We're going to solve this exact same one here. But we're going to take advantage of our knowledge of ratios and the order that we compare them. Specifically, when I have 3 over x is equal to 5/9, in our last lesson, I had you spend all the lesson flipping it to its reciprocal, right? 3 over x is equal to 5 over 9 can be flipped to x over 3 is equal to 9/5. That's why we spent a whole day going over that, so that we can take advantage of this property. So we're doing it again, but this time we're going to take advantage of our knowledge of ratios and the order we compare them, flipping them when we want to. So what do we write here? It's given. That's just a problem that's given. First thing that I'm going to do is flip it. Okay, so 3 over x becomes x over 3. And 5 over 9 becomes 9 over 5. What property says I can do that? Let's just call it reciprocal proportions. I'm making it up, but let's call it reciprocal proportions. Okay, at this point, we have now flipped it. Doesn't this look a lot like the like the first version of that problem? As in identical, right? So do we know the steps that we're going to take to solve it? Let's solve it. X is being divided by 3. I'm going to undo dividing by 3 by multiplying by 3. I'm just going to show my work here. I'm undoing this division with multiplication, balancing it, and doing the same thing to the other side. What says I can do that? Multiplication, property of equality, specifically choosing multiplication property of equality because I want to undo the division. And what happens when we do this? The 3 and the 3 end up multiplying out, leaving me with x is equal to 9/5 times 3. Sorry, yeah, 9/5 times 3 is 27/5. Again, how did we get there? We just simplified. So now, my question to you folks. Which version did you like solving the best? Did you like solving the x divided by 3 equals 9 divided by 5? Or the 3 divided by x equals 5 divided by 9? Which one did you prefer? Talk with your groups. Talk with your groups first. Okay. I think that was a resounding, I'd rather solve this first one, right? I agree. I would rather solve this first one as well. So what happens if you're given the second one? What's a good strategy if you're given the second one? Knowing you liked solving this one better, what would you do, Luke? Yeah, we would reciprocalize it. We would flip it. Because if I get it like this and I'm like, ooh, I don't like that one, all we have to do is flip it using that reciprocal proportions, and boom, it's as easy to solve as that first one. Okay, now we're going to solve this one more way. We're going to go back to the first version of the problem and solve it again, but we are going to pretend like we are afraid of fractions and get rid of the fractions early on. Okay, pretend like we're afraid. We're like, oh no, I don't want these fractions. We're going to get rid of them. Okay. All right, with me. If I am afraid of fractions, sorry, let's back up. This is the first one, and it is given. What I'm going to do, if I'm going to pretend like I'm afraid of fractions, I want to get rid of both denominators. Okay, so I'm going to get rid of this denominator of 5 by multiplying by 5. Is that okay to do that? As long as we do it to the other side, right? That is only going to help me out and get rid of this one. What do I need to do to get rid of this denominator here? What do I? Multiply by 3. And that's okay to multiply by 3 as long as we multiply this side by 3 as well. Okay, looks messy, looks crazy, but we have done things that are okay to do. However, I didn't color code quite the way that I wanted to, so hang tight. All right, so let's try and justify this. I'm just going to write multiplying by denominator gets rid of fraction. And really, truly, isn't this just multiplication property of equality? Yeah. This next step, we're going to simplify. So when I simplify, what happens here? 3 times the 3 on the denominator, that multiplies out. So what am I left with over here on the left-hand side? 5x. And what happens here? 5 times the 5 in the denominator multiplies out. What am I left with here? 9 times 3, which is 27. And we're going to call that simplify. I think I'm going to do something a little bit different. Instead of writing 27, I'm going to write 9 times 3. I'm not going to simplify that part. Last final step. We're going to take that 5x is equal to 9 times 3. How are we going to undo what's happening to x now? We divide by 5. Whatever I do to one side, I do to the other side. We're going to call this the division property of equality. Why am I choosing to use the division property of equality? Because we want to undo multiplication. Last step, and we are just about out of time. Let's simplify this. 5x divided by 5 divides out, leaving me with x is equal to, and we can actually officially simplify now. 9 times 3 is 27 divided by 5. Doesn't simplify nicely, so we keep it 27/5. That was still a lot of work, wasn't it? You thought that the last one would probably end up being the easiest. It wasn't, was it? Please remember that. I'm going to teach you something tomorrow. You have been taught in your previous math courses that this is the best way to do it. Do you agree that this is the best way to do it? After your experience, I think that we agree this was quite a bit easier, right? Okay, keep that in mind. We're going to continue this lesson tomorrow, but it is time to get cleaned up. Thanks for watching, and we'll see you next time.